So the problem that we had to work with here, we wanted to know, oops, come on. There we go. What is 5 halves times 4/3? And in order to do that, I asked that you model multiplication as area. So next thing I want to note, multiplication is an area, and area is base times height. So then this particular problem, rewritten in terms of that, I want to know what is an area base 5 halves and height of 4/3. So I got to come up, figure that out. So I started trying to lay out my area here. So here's, I'm starting to draw my height, I'm starting to draw my width. So, and again, I'm trying to draw with my mouse instead of my fancy pen and pad, so this is a little messier than usual. So I started measuring a line out here from my base and then realized, okay, I got to figure out where 5 halves is. In order to do halves, I need to know what a hole is. So I said, okay, let's let this mark right here be 1 hole. So I'm just going to label that. That's 1 hole right there. So that's my second hole right there. I want to show 5 halves. So there's 1 half, 2 halves, 3 halves, 4 halves, and I kind of need to know where 3 is out here to get 5 halves in the right spot, but I can kind of see how long a half is, and so right there, that's going to be 5 halves. So notice I'm not trying to apply an algorithm here, I'm trying to apply what multiplication means. Got to go the same thing the other way. Now usually it's a good idea if you decide that this length here is 1 hole horizontally, try to do the same length for 1 hole vertically. So I made my 1 hole there. I need to show 4/3. There's 3/3 in a hole, so that means I need a second hole so that I can mark off some thirds to identify where 4/3 is. So in a hole, there's 1, 2, 3/3, and so this one right here is my 4th third. So there is 4/3, written out with my mouse. So now I'm just going to continue some other lines to show my area. This is the top of my area here. Come on, mouse. Come on, hand. You got this. That's not bad. And then this is the width coming up from there. So that's my answer. My answer lives in that box. Now, another thing I have to remember in order to do this is a fraction is an equal part of a whole. So I'm going to add that up here. I need to know what a hole is, all right? Let's figure out what a hole is. Well, I'm going to pick a different color for that. Let's use blue. 1 hole is 1 by 1 in terms of area. So here is 1 hole, and there's another hole right here. So I can see there's 2 holes in this answer. Then there's this other stuff in this L shape up there. Well, what the heck is that? To figure that out, I got to go over the parts of a hole. So in do different color, back to green, I'm going halves this way. So there's my halves drawn through. And I'm doing thirds this way, so I should draw those through. Getting a little better drawing with my mouse here. And then there's that one. Oops, I forgot to draw that one up there. All right, so I draw in all my halves and my holes. I'm just going to whip up my highlighter. It's a highlighter. Let's go yellow. So I've got, right, remember, this is 1 hole. That doesn't look like a highlighter. So it's a highlighter. Okay. It's different than when I was using it before. Oh, I guess it's doing that whole chisel tip thing. Oh, that's cute. Job, Jamboard. So there's 1 hole here. So I'm just going to add to my note up there. Fraction, oops, I guess I got a new note, is an equal part of a whole. There are 6 pieces in. So that's another important piece to this puzzle. Move, please. There you go. So that's part of this too. So there's one of the holes there. Let's draw in the other hole and count up some more. So let's see, if I go from here, 1, 2, 3, 4, 5, 6. So here's another hole right there. And then I have these 2 extra pieces. So one version of the answer, looking at this, pen, green, is the area seems to be 3 and 2/6, because I have these 1, 2 pieces down there, and 6 pieces make a whole. Another way to talk about the answer is the total number of pieces that I talked about before. So I could also say this grid I've made has 1, 2, 3, 4, 5 columns and 4 rows. 4 times 5 is 20. So another answer here is there are 20 pieces in my area, and those pieces are sixths. So I could say the answer is 3 and 2/6, or I can say the answer is 26 on what I have so far. Questions on that yet? I hear no voices. I see no chat. Does that mean it's good, or you're afraid to ask?
I'm good.
Okay, so thank you for voicing that. Now I noticed looking at some of the other slides is there were different answers than I have here. So I saw 3 1/3 and I saw 10/3 out there. So how could I justify those? And the answer there is a lot of people would realize, oh, the 2/6, that can be reduced. Okay, so how would we reduce that? Well, we would divide top and bottom by 2 here. So that means I'd have to group by 2. So I'm just going to make another note to myself off to the side here. Let's group little pieces by 2. And let's put an extra T in little so it looks better. So my picture's about to get messier. What should we do? I haven't tried the paintbrush yet with a marker. I'm going to stick with highlighter. And let's go with, sure, green this time. So looking for groups of 2. So there's a group of 2 right here, and another group of 2, and another group of 2, and another group of 2, another group of 2, and another group of 2. Whoa, a little carried away there. Another group of 2, and another group of 2, another, and another, and another. All right, so I've reduced this a little bit, and so now I'm just gonna try and figure this out. Let's see, pen, and let's go with blue. So with this answer up here, I've got a whole bunch of groups of 2. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. And each of those pieces, you'll notice that there's 1, 2, 3 of them in a hole. 1, 2, 3 of them in a hole. So the answer's got to be 10/3 because there's 3 pieces in a hole of that size piece. So there's the 10/3 there. And over here, again, I'm realizing, hey, there's 3 in a hole. So instead of 3 and 2/6, the answer is 3 and 1/3. So I got a whole bunch of different answers. They're all correct. I think most people would argue that the blue ones are the best answers because they're reduced. So either 3 1/3 or 10/3. So this one was a little harder than the problem I did before. The problem I did before did not reduce in any way. This one did, so we had some extra steps there. But what's the process here? The process is to not know what the answer is and try and draw a picture of it. The process is to understand what fractions and multiplication mean, which is all this information here, and come up with a product, come up with the answer. So since again, you're not quite comfortable with this yet, you're still trying to wrap this around, wrap your brains around this, it's natural to say, okay, I remember that I'm supposed to multiply numerators and denominators, so the answer should be this, right? So I think everybody recalled that if we want to take, let's write them in the right order, 5/2 times 4/3, the procedure is to multiply numerators. 5 times 4 is 20, and to multiply denominators, 2 times 3 is 6. So a lot of groups started off with that and tried to justify it with a picture, which is backwards of what I was hoping. But I totally understand taking that approach. Further questions? Okay. Oh, what's up?
So you would be okay with either this 3 or 2/6 or the 3 or 1/3, either answer?
Yeah, so suppose if this question were on a test, if you had stopped with the 3 and 2/6 or the 26, that'd be like 80, 90% correct. Because it can be taken just a little bit farther. So I'd expect you to do something to justify that regrouping here to get the simplest answer. So the best possible answer would be either 3 1/3, or 10/3. Either one would be the best answer there. 3 and 2/6 and 26 would be mostly correct. Good question. Other questions? Okay, so we're going to stop on this one.